Hey everyone, in this video we are going to solve the LRU cache question on Leetcode. So we have to implement a data structure named LRU cache such that it has three things in it. It has a capacity which will be provided to it, and then two or more functions, get and put. Get will return us the value present at that particular key, and if that value does not exist, it will return -1. Another function is put. It will take a key value pair and it is used to update the key value pair if the key already exists. Otherwise, insert the new key value pair to our cache. And we have to make sure that whenever the capacity of our cache exceeds, we need to evict or delete the least recently used key from our LRU cache. So there are two ways to solve this particular question. One is to simply use a hash map or a map data structure in JavaScript. And the other way, or the more popular way to solve this particular question, is to use an object literal or a dictionary along with a doubly linked list. We'll be solving this particular question using both of these solutions. So this is the question. Let's see how we can do it. So the first way to implement an LRU cache using JavaScript is to use a hash map or the map data structure present in JavaScript. What it will do, it will store two things: key value pairs, key and a value. It is similar to an object, but it provides us some other things as well, like it returns an iterable. And for a map, the insertion, access, search, or delete, all of these things happens in O of one time, which is a requirement for this question. And let's suppose our capacity for this LRU cache is 3. So we cannot store more than 3 items in our cache. And remember, when we get or when we try to access something, that item will become the most recently used. So in an object, we'll have two things. The element present at the bottom will be our most recently used, and the element present at our top will be the least recently used. So let's understand this with an example. So let's say first we have an operation of put. So we have a key of 1 and a value of a to put. So we insert a 1 as a key and a as a value. Up until now our capacity becomes 1. We can add more, right, because we have a capacity until 3. Next we have another put operation, 2 comma b. So we insert another key 2 with the value b. Now, as per the question or as per the definition of LRU cache, this 2 is our most recently used item because it is recently inserted to our LRU cache. In this hash map, the top one represent the least recently used and the bottom one represent the most recently used. So right now, 2 is the most recently used and key 1 is the least recently used. So if we try to perform a get operation now, get 1. So now this 1 should become the most recently used and this 2 should become the least recently used. That's how the LRU cache works. So what we need to do, somehow move this 1 comma a to the end of our hash map and move 2 comma b on top. So what we'll do first, whenever we get an item, so whenever we have to perform a get operation, we have to perform two things. First we delete that key and then we insert it again. So what will happen when we perform the get operation for key 1? First we'll delete it from our LRU cache, then again we'll insert it at the end. So we'll again insert 1 comma a. That's how we're going to perform the get operation. So whenever we perform a get operation, first we'll delete that particular item from our LRU cache, then we'll insert it again. Why so? So that again the property maintains that the element present at the bottom is the most recently used and the element present at the top is the least recently used. Right now, item with key value pair 1 comma a is the most recently used since the last operation was performed on this particular key. Right now our capacity is 2. Now let's say we perform another put operation and we'll call it 3 comma c. So we'll insert 3 and c. Now this 3 comma c will become the most recently used item in our LRU cache, and our capacity will become 3. Now our capacity is full. But what will happen if I perform another put operation with key 4 and a value of d? So now what should happen by the definition of LRU cache, that this 2 should be removed, because right now this 2 is the least recently used item in our cache. So first we'll add it. We'll add 4 comma d to our cache, and at the end we'll delete the least recently used item from our cache, which is 2 comma b. Then this 4 comma d will become the most recently used. That's how our LRU cache will work. We're using this single data structure map in JavaScript. So let me show you how it will work in console as well, so it will become more clear. Okay, so I have opened my Chrome browser here. So in the dev tools in the console, if I declare a variable, let's call it map equals to new map. That's the syntax to create a map or hash map in JavaScript. Now I want to perform the put operation. So for that, what I'll do, map dot set, and I'll provide the key and a value. So let's say the key was 1 and the value was a. So if I press enter, so we have a map with a single item in it of key 1 and value a. Let's perform another put operation. This time key 2 and value b. Now we have two items in our cache, 1 comma a and 2 comma b. Now if I want to perform the get operation on 1, right now the most recently used item is at the bottom or at the end of the map, which is 2 with key 2 and value b, and the least recently used item is at key 1 value a. Now if I perform a get operation on 1, if I try to access key a in this LRU cache, in our LRU cache, what should happen is this 1 should go to the last. Okay, this 1 should go to the last and 2 should be at the top, and this one should get deleted. So how we can perform it? What we'll do, we'll write map.keys, and it will return us an iterable which has a dot next function in it. And if I call the dot next function, it will return us me the value, the first value from the map data structure. Okay, now I get the value, and first this is the least recently used value. This will be the least recently used value in our LRU cache, the value which is present at the top, which is key 1 value a. And now I want to perform the delete operation on it. So map.delete map.keys.next.value. So whenever we perform a get operation, first we'll delete the least recently used one, which we'll get using map.keys.next. So it will be key 1 value a, and if I press enter and then again print our map, now we have only one item present in our map, which is 2 with key 2 and value b. Now our get operation is still not completed yet. First we deleted the key from our map data structure. Now we need to add it again. So we'll again call map.set 1 comma a. So now our LRU cache will become 2 comma b, 1 comma a. 1 is moved at the bottom of the map data structure and 2 is at the top. So now 1 is the most recently used and 2 is the least recently used, which should happen when we perform any get operation on a key. Now let's say if I push another item in it, let's call it 3 c. Now our map have 3 items in it. What will happen if I try to perform, if what will happen if I try to add one more item, and our capacity is 3, and if our capacity is 3, right now it will add it just like this. But what should happen when we are implementing an LRU cache is that this 2 comma b should get deleted. Everything else is fine. Key 1, 3 and 4 is fine. Only the least recently used, which is 2, which is key 2 and value b, this one should get deleted. So whenever we perform a put operation and the key and the size exceeds, so what we'll do first, we'll perform the same thing. And if I print the map again, now we have the updated LRU cache. So that's how we are going to implement the whole LRU cache using the single map data structure in JavaScript. If it is still not clear, it will get more clear when I write the code. So let's see how we can do it in code. So instead of using this prototypal inheritance structure, I'll be using the classes in JavaScript so that the code is more readable and understandable to most of the people. So I'll remove this whole thing and I'll write class LRU cache. It will have a constructor first of all to initialize a variable, and it will take capacity as an argument. And inside this constructor we'll initialize two things: our map data structure, which is this dot map equal to new map, and our capacity for our map data structure, which is this dot capacity equals to capacity. Now this LRU cache is going to have two methods, which is get and put. Get will take a key, and another function put, which will take a key and a value which needed to be inserted. Now let's start with the put method first. Okay, so what if the key is already present in our map data structure? So what we'll do, we'll just write this dot map dot delete and pass it the key to handle that condition, and map will handle the edge cases that if the key does not exist, then what will happen. Next we'll insert it to our map data structure, this dot map dot set, and we'll provide it the key and the value. Now this is it, we have inserted the value in our LRU cache. Next thing, we need to check if the capacity of our LRU caches is exceeded or not. So we'll check if this dot map dot size is greater than this dot capacity. So if the size of our map is exceeding our capacity, in that case we need to delete the least recently used item. So to access the least recently used item, what we'll do, we'll write const least recently used item, and to access it we'll write this dot map dot keys. It will return us an iterable. Then we'll call the next function. It will return us two things, a value and done, and another property done, which is how iterables work. It returns us two things, a value and a done property. Every time this done will be false until we have looped through all of the items in the iterable, and then we'll get the value. So in this LRU item, we'll get the key of our least recently used item. Now we just need to perform the delete operation, which is this dot map dot delete, and we'll pass it the key, which is LRU item. So this whole code is for our put function. Now about the get function. So first we'll check if the element is present in our LRU cache or not. So we'll check if it not of this dot map dot has key. So if the key is not available in our map, then we'll just return -1. Else, if it is present in our map, if it is present in our LRU cache or in our map, we need to return it. So first we'll fetch it or access it using this dot map dot get, and we'll pass it the key which we want to access. It will return us that key value pair. Now before returning it, since it is a LRU cache and we are performing a get operation, the key, this key will become the most recently used item in our LRU cache. And in order to do that, first we need to delete this key and move it at the end of our LRU cache. So for that, we'll write this dot map dot delete. First we'll delete this key and then we'll insert it again. So this dot map dot set key comma val, key which is provided to the get function and value which we fetched from our map. And at the end we'll just return that fetched value, which is return well. So this is our get function, this is our put function. So if we run this, it's working. Let's submit it. Cool. So that was the first approach to solve this particular question. Next, we'll see the other approach, which is using a doubly linked list and an object. So the other way to implement an LRU cache, which we will see on most of the channels and most of the blogs, is to use a map along with a doubly linked list. So what we'll have is a map data structure with key value pairs in which a key is a normal key, but a value is a node from their doubly linked list. So let's understand this with an example, like how it will work. So let's say our capacity is 3, and first we perform a put operation of value of key 1 and value a. So what will be stored exactly in this particular case? We'll have map object and it will have a key of 1, and inside that value, but in the value will have a node, a linked list node of that doubly linked list. And since it is a doubly linked list, it will have two things. It will have the value, which is 1, and key, both of them. You can have both of them, and the other two things will be the link to the previous node and the link to the next node. Since it is the first node, both of them will point to null right now. Now let's say another put operation is performed. This time the key was 2 and value was b. Now this key will be 2 and value will be another node in the linked list, which will have three things again: linked to the previous node, the value of that node, and the link to the next node. How it will work is the first one will be the head and the last one will be the tail of the linked list. The head will point to the least recently used item and the tail will always point to the most recently used item. That's how it will work. And also, once we inserted the second node, this next pointer will point to this node and the previous pointer will point back to the next node of the head, like how it works in linked list. And in this case, this next will point to null. Cool. But now what will happen if I try to access the node with key 1? In that case, what will happen? This 1 should become the most recently used and this 2 should become the least recently used, right? So what should happen? Somehow 1 should become the new tail of the linked list. So this tail will always represent the most recently used item. So whichever element we are performing operation on, either it is a get operation or a put operation, that particular key will become the most recently used item. And the head of that linked list, of our doubly linked list, will always point to the least recently used item. So whenever we have to remove an item, we know that we have to remove the head. We need to update the head of the linked list. And all of these operations will be performed in O of 1 time. So let's see in more detail how it will work. So when I try to perform a get operation on key 1, what should happen? Like in similar case of a map data structure which we're using, same thing will happen. First, we'll delete or remove that node or that item from our LRU cache, and then we'll insert it again to our LRU cache. So what will happen is this head will be removed. One thing to remember, when we are removing the when we are deleting the value from our LRU cache, we need to update these previous and next pointers as well. So when we are going to do that, what will happen? This the previous of the tail will point to the previous of the node of the head. So this will point to null. This connection will be cut, and then the next of the head node will point to null. And then after that only we'll delete this node from our linked list, from our LRU cache. Then again we'll insert it again with the same value. It will again have three things: previous, the value 1, the value a, and then the next node, the pointer to the next node. And also this previous pointer will point to the this node. This will become our new head, and this will become our new tail. And the next pointer of this head will also point again to the previous of this node. So it's getting quite messy here. Let's understand it with a clear example again. Okay, so we'll have our map here, our map object here. It will store key value pairs. Now let's say we perform a put operation first. We perform put 1 comma a. Now what will happen? A key value pair will be stored in our map. Key will be 1 and value will be a node of a doubly linked list, which will have two things: the previous pointer, the actual value a, and the next pointer. Right now this is the first node in our linked list, so it will be the head as well as the tail. And right now previous and previous and next both will point to null, since it is the only element present in the linked list. Now next we'll perform another put operation, which is 2 comma b. So what will happen? Another value will be inserted with key 2, another linked list node with a previous pointer, the value, and the next pointer, and will connect this node with the previous node, the head of the linked list. So the next pointer will point to previous, and previous will point to next, and so on and so forth. The head always represent the least recently used item. I'll write here head always represent the least recently used item, and the tail always represent the most recently used item. So whenever we have to perform a delete operation, we know we have to update the head only. Okay, now let's say we perform another put operation, or let's say we perform a get operation. This time we perform a get operation, and this time I tried to access key 1. What will happen? This should become the tail of the linked list now, because that's how our LRU cache works. Tail always point to the most recently used, and head points to the least recently used. One thing to remember: before before deleting it from our map directly, first we need to update these pointers as well. Since there are only two elements present in it, so we'll point tail previous. So tail dot previous will point to head dot previous, and then head dot next will point to null. So this will point to null, and this will point to the null, which was previous head's previous pointer. And now this connection is lost between these two nodes. Now we can easily successfully delete this one from our LRU cache, and then we'll insert it again. This time we'll insert the node insert with key 1 and the same linked list node with the previous pointer, the value, and the next pointer, and this will become our new tail. The previous one will become our head, and then we'll establish this connection. The next pointer of this head will point to here, and previous pointer will point to here, and both the previous pointer of head will point to null, and the next pointer of tail will point to null, and so on and so forth. Okay, so let me update this quickly. So this is how our linked list will look. Now let's say we perform another put operation now, and we insert the key 3 with the value c. Now another node, another value will be inserted in our map will with the key 3, and value will be another node of the linked list, which will have again three things: the value, the previous pointer, the actual value, and the next pointer. Now this time, this should become our new tail. So we have to write the code to update this particular node as the tail of the linked list. So what will happen? This this next pointer of this node with value a will point to here, and the previous pointer of this node will point to node a, and this one will become the tail. Now our capacity has reached to our max. We have 3 items in our LRU cache and we have reached our max limit. Now if I perform the put operation again, and this time I performed 4 comma d, this time we know that our head always point to the least recently used item. So this node, the first node, the head need to be updated now, and we need to insert the new node at the end of the linked list. So what will happen? Another node will be inserted with key 4 and another linked list node with three things: previous node, the value d, and the next node. The next one will point to here and the previous one will point there. The next one will point to here and this will become the tail. And we need to remove the head now. We need to update the head. So again, before removing it from the map data structure, first we need to update the pointers. So this one, so the previous node of node A will point to the previous of head as we wrote here. So this will point to null and this will also point to null. Then we'll successfully delete this item from our map data structure, and this one will be updated as the new head of our linked list. So that's how things will work. It will become more clear once we wrote the code for it. So this is the drawing explanation. Let's see how we can do it in code. Okay, so let me first clear our get and put function. Along with the map data structure, we'll have one another thing, which is our doubly linked list. So we'll write it as this dot dll equals to new doubly linked list. We'll create this linked list class soon. Then we'll write the code for the get and put operation. So first let's define the linked list class. Before that, we need to define the node class as well, which will be a node, a single node of the linked list. It will have a constructor in it. It will take two things: key and value. So this dot key will point to key. This dot val will be equals to val, and it will have another two pointers. This dot next equals to null, and this dot previous equals to null. Now time to write our doubly linked list class. So class doubly linked list, it will have a constructor. And this doubly linked list will have three things. First is the head. Initially it will point to null. Then the tail of the linked list. And then another value called length. And this head will always point to the least recently used item, and the tail will always point to the most recently used item. And this linked list will also have two things in it. Either we want to push something into the linked list, or we want to remove something from the linked list. So let's write the function push to push something in the linked list. It will take two things: key and value. First we'll create a new node. We'll call it new node equals to new node. We'll pass it the key and the value we got from this push to the as an argument to this push function. Next, we'll check if the linked list is empty. So if this not of this dot head, that means there are no elements present in the linked list currently. That means the single node will become the head, and it will also become the tail. If there are some elements present in the linked list, then we need to insert it at the end of the linked list. That means it will become a new tail. So for that, what we'll do first, this dot tail dot next will point to the new node, and the previous of the new node, so new node dot previous, will point to this dot tail. Now we have successfully established the pointers. Now we can easily update the tail of our linked list. So this dot tail will now become the new node. This new node will become our tail of the linked list. Another function will be a remove method, and remove function to remove a node from the linked list when we want to update the head property in order to maintain the least recently used and most recently used items. So in also while removing, there will be certain cases. So first case will be that the element that there is only one element present in the linked list. So if that is the case, that means we need to empty the linked list. There will be no elements left in the linked list. So if not of node dot next and not of node dot brief, not of node dot brief. So if there are no next to it, no element present next to it, no element present left to it, that means we have only, it was the only element present in the linked list, and now we need to empty the linked list. So this dot head will point to null, and this dot tail will also point to null. Else, sorry, else if actually. So another thing can be that the node we are trying to remove is actually the tail node. So how we'll know if it is a tail node? The next pointer of this particular node should point to null. If the next pointer of this node point to null, that means it is a tail node. So if not of node dot next, that means it is a tail node, and we are trying to remove a tail node. What we'll do? This dot tail will point to node dot prev, the previous node to this tail node, because we want to update our tail node now. And this dot tail dot next will point to null. Now by doing so, we have successfully removed our tail node. Else if, another example can be if we were trying to remove the head node. And how we'll know if it is the head node? If the previous pointer of this particular node points to null, that means it is the head node. So if not of node.prev, node.previous does not exist, that means it is the head node. And first we need to update the head node, the head of the linked list. So this dot head will point to node.next. And then after we have successfully updated the head, then only we'll remove the connections to this particular node. So this dot head dot previous will be equal to node dot next. Else if it is not the head, it is not a tail, that means it is a node which is somewhere in between. That in that scenario, we first need to get the previous node, which is node dot prev, and also the next node, which is node dot next. Then we'll point prev dot next to next, and next dot prev to prev. So let me show you a diagram what we are exactly doing here. So let's say this is the scenario we are facing, and we want to delete this B node from here. What we'll do is we get the previous node and next node to it and store it in a variable. So this will become previous and this will become next. Don't confuse this with this previous and next pointer. These are just completely different variables. Let me call it like a previous item and next item. Okay, so now what we need to do, we need to first remove these connections of the previous pointer and next pointer. So what we want to do, we want to point the previous pointer of tail to the node to which this previous node pointer was pointing, which is the head, and we want to point the next pointer of the previous node, which is head, to the node to which this next pointer was pointing, which is the tail. So what we need to do, we will point previous item dot next. So previous item dot next, this particular node should point to the node dot next, this node, and next item dot previous should point to node dot previous. So by doing so, we have connected the remaining nodes, the previous node and the next node, with each other, and now we can successfully delete this node from here. So that's what we are doing in that code. And now once we have removed the node, we need to reduce the length property. So this dot length, I'll call it minus minus, and also when we are adding it, we need to update it. So here we need to update it. So this dot length plus plus, and also this push function will return us the node which is inserted. So we'll also return it from here. So return new node. Cool. Now coming back to our LRU cache class. So new map. Oh, this one won't be a map, because if we are using a map data structure, we don't need to use a doubly linked list. So it is a normal object, not a map. So what we are using a doubly linked list and a normal object literal in JavaScript. So first let's write the put function. So first we'll check if that key is already present in our map. So if this dot map key, so if this particular key is already present, first we need to delete it from our linked list. So this dot dll dot remove, and this dot map and key, we pass it the key. Cool. Next we need to set this particular key. So this dot map at that particular key will store the node of the doubly linked list, which will get from this dot dll dot push, passing key and value. So this push method will return us the new node or the linked list node, which will be stored as a value in our object literal. Next we need to check if the capacity or if the length of our linked list exceeds the capacity of our LRU cache. So for that we'll write if this dot dll dot length is greater than this dot capacity. So this length is coming from the constructor. We declared it in the constructor of the doubly linked list. So if the length of the linked list is greater than the capacity of our LRU cache, in that case we need to update the head, since the head of our doubly linked list point to the least recently used item. So first we'll get the head. So const current key will be equal to this dot dll dot head dot key. We got the key of our head, of the head of the linked list. We can remove this item from our map object using delete this dot map and pass the key. Now we also need to update the head of the linked list. We need to remove the old head, and we need to update we need to delete the old head and get the new head of the linked list. So for that, what we'll do, we'll write this dot dll dot remove, and we pass the head of the linked list. So this dot dll dot head. So what it will do, it will go to this particular scenario when node.previous does not exist. It will first update our head to node.next, and then remove all the connection of the previous old head. So this will be not, this won't be node dot next, it will be null. Cool. So this will be it for the put function. Now let's move to the get function. So for the get function, first we'll check if the value is not present in our object literal. So if not of this dot map at key, if it is not present, in that particular case, we'll just return -1. Else, first let's get the value or the linked list node present at that particular key, which will be this dot map at that particular key dot val. It will return us the linked list node present at that particular key. And remember, for the get operation, first we delete that node and then we insert it again so that it becomes the new tail of the linked list. So to delete it, to delete this, we'll write this dot dll dot remove, and we pass this dot map at that particular key, the node at that particular key, and at the end we'll insert it again to a map, to a map object literal. So this dot map at that particular key will insert this dot dll dot push and passing it the key value pair, and at the end we'll just return that value which we recently inserted in our LRU cache. So this will be the get and put method for our LRU cache, and this will be the whole code. So let's try to run this. It's working. Let's submit it. Cool. So that was it for this video. Thank you for watching.